Okay, good morning, Clara. It's actually now it's 9 May. I think you took the ACT yesterday. So, sorry I haven't gotten back to you on this. But probably you'll keep studying. So here was the questions that you sent to me. This one was something I'll paraphrase here. So there's a little story, and then there'll be a linear equation. You could write that as all of these would be in the form y equals mx plus b, where the m and the b are, I guess, what you call constants. See that 108 there? You could mess this around. This one is kind of like y equals b minus mx. Okay, so you got a rate here, a rate and a starting point. So you got somewhere where you start, and you got a rate that changes by a lot of times it's time or distance, something real simple. And then you got your result, which you're keeping track of. Okay, so Kathy repairs phones. At the end of each day, she's got P phones left. This is number 4. And so she's got this equation that models this situation, right? So the thing I think you might like about this math, and I don't know if you've had anybody propose it to you like this, is that you have a story, right? You have a story, and then you got a little math equation that goes with it, and you got these two variables in the story. I don't know what you call that when you're writing. You got a character and it's something they're doing. Anyways, so she's going to have P phones left to fix, and D is the number of days she's worked. So she starts. So then you kind of break down this story. So the 108 is where she starts. So this number that's by itself in these linear equations, in these straight line equations, in straight line, no exponents on x. Nothing fancy, just an x with an exponent of 1. Not that there's no exponent, there's an exponent of 1. Right? If it's an exponent of 2, it makes gets complicated. Okay, more complicated. Not too complicated. Okay, so she got a start point, and every day, D is the number of days she's worked. So every day she works, what happens? She fixes 23 of them. So there'll be some question. What in this one? In what cases? What is the 108? Well, the 108 must be where she started. You could sketch this on a little graph, I guess. So that's another part of the little puzzle. So you got a story, you got an equation, you got a table. So in these little algebra things, you got a story. Story's kind of boring and short a lot of times, and then you got a table of values, which is also your points. It'd be points on the graph, x comma y. In this case, it'd be d comma p, right? And then you got an equation that maps these points. Like if you put in a D here, she's worked 2 days. Well, how many phones does she have left, right? The equation maps out these points. And then, what's the other part that you have? Equation, story. Oh no. There's another part of this, and I'm the graph. Oh, we got graph paper. So you got all these parts that can tie together, right? And in this case, they give you the story and the thing. And I know I'm talking too much here, and I should just give you an example of work. But I'd like you to think of that. And of course, we could graph this out, and you got to think about your dependent and your independent variable, right? On the x-axis, this would be your d-axis, I guess, in this case. If I've got P equals 108 minus 23D, Well, days. If you got time in your equation, you don't need to graph all this. I know that, but I'm just getting silly here, kind of showing you how these things work, I hope. Um, and that way you can break it down and think about it. So you got days, and then over here you'd have your number of phones, and you're starting up here somewhere. I don't know, what would these go? 108 divides into 12s, right? Is that right? 108. Yeah, 96. 8 times 12, 96. 9 times 12, 108. Anyways, I should have graphed it bigger, I guess, but I don't have a good eraser now. So let's go by 24s. 24, 48. This would be 96 here, and then we'd have 108 right here. Half of 24, right? So she starts up here on like day 0 at the beginning of each week, and then takes away 23 each day. So there's your, this is your slope. This is your rate of change, minus 23 phones every day. So she starts 108 phones, and then she's going down almost at a rate of 24 if this is a day here. And my scale's all weird, but anyways, this would be right over here somewhere. So you could go after one. Sorry, this would be day 1. Here's 1 day, 2 days, 3 days of the week. Like, when does she finish this? Well, she'd finish when she's got 0 phones left, right? She's got 0 phones left. You can put a 0 in there and solve for D. 0 equals 108 and find where this hits here. Okay, but we can also go down every day, 23 phones gone. So 108 on the next day, she's got, what's 108 minus 23? Oh, goodness. 15, which is 85? Is that right? I think 85. Just be down to 85 right here. So your points right here that you're getting is part of this little puzzle over here. The points you'd be getting is at day 0 she's got 108, and then at day 1, at the end of day 1, right? Didn't say that number of days she's working. So the end of the day, or the start of the next day, at the end of day 1 she has 85, and so on and so forth. And then, and it's going down like a straight line. This is a perfect world, right? She never does 22 phones and never does 24 phones, whatever, So that gives you an idea, and then you can find out when she finishes, right? Okay, so this is getting really long. Sorry, this is too long. So that explains that one. Let me give you another little problem. Say the Uber driver makes money. He gets paid for any drive. He gets paid the money he makes. The charge. The money he makes equals 7 plus 1.50 m. And m is the miles he drives. So that's the usual one. Something like that, where your rate keeps increasing. So then it would ask, well, what's the 7? You can pause this and think about what would that 7 be. If this is so the 7 is, he charges that before he starts the meter. So he's got a little thing that already, it's going to give him $7 or whatever reals, dollars, whatever your money is, euros, plus 150 per mile he drives. So all these similar like that. I hope that helped a little bit. Too long me just talking, but I'll get better at these.